Question, let's start with displacement since it's a little bit more time consuming. The boat travels 30 nautical miles east, and then he goes 20 nautical miles south, and then 5 nautical miles west. So there's 3 different transitions. D1, there's a displacement, 30 nautical miles east, and you're adding to that D2, which is the 20, and adding to that D3, which is the 5. And we're trying to figure out what the total displacement is when we add all those vectors up tip to tail. Now you can add vectors in any order. So I recommend doing the east and west ones together because they'll cancel off. So if I go 30 nautical miles east and then 5 nautical miles west, overall that's 25 nautical miles east. So if I write these in a different order, if I go D1 plus D3 plus D2, makes no difference what order I do it in, I can simplify D1 and D3 into 25 nautical miles. So those two become 25 nautical miles, and that's east. And we're going to add that to the 20 nautical miles south. So my diagram looks like this. He walks 25 overall to the east. Then he changes direction tip to tail and does 20 nautical miles to the south. And his overall displacement points from start to finish as usual. So there's where he starts, there's where he finishes. So overall displacement is like that, and I always put 2 arrowheads on it. Now, how do we calculate that? Well, you can see you've got a right triangle. A squared plus b squared equals c squared. Simple Pythagorean theorem. And when you do that, you get a total displacement of 32 nautical miles. Now, what about the direction? The direction, which we'll do in blue, we always want to go back to the beginning of the vector and state the direction with respect to either a horizontal or a vertical. Either one of these angles are going to work for us. So if I solve for this little horizontal vector, you can see that I've got a triangle where the opposite side is 20 and the adjacent side is 25. And I can pair that with tan. Tan theta is opposite over adjacent. And when you do the inverse tan to actually solve for the angle, I get theta is tan inverse of 20 over 25, and you get an angle of 39 degrees. And if you look at where that angle is located, that's south of the east line. My overall displacement, when I write it properly, would be 32 nautical miles at 39 degrees south of east. Now, what about distance? Distance is easy. It's just a path length. So I don't put the little arrow above it, and all I do is I add up all the individual path lengths. So I get 30 plus 20 plus 5, and I end up getting 55 nautical miles.